Hey everybody, this is Tim Smith. This is Fresh New Chef Stuff Episode 2. Today we're going to be talking about testing with ChefDK in Travis CI. So let's start with a little bit of the state of cookbook testing. It's probably just a gem file. It looks something like this. We got a few groups in here. We've got a random fog gem shoved in, a little bit of test kitchen, a little bit of unit testing, a little bit of lint. Nothing really amazing. And if we're lucky, maybe we have a Travis setup, right? Like pretty simple thing. We're testing here in Ruby 2.18. We're installing without that development group. We're doing a Burks install, and then we're running Food Critic, Rubicop, and Chef Spec there. Nothing really amazing. What's wrong with it though? Well, to start with, it's kind of a bit unclear, right? Like, what do I do with that gem file? Do I bundle install that? Do I bundle update that every time I run the tests? Like, how do I know that I have the right thing? It's probably out of date. Like if you looked at that gem file there, like that was wildly out of date, right? Like I'm testing with gems that are 3 major versions out, and that really wasn't that bad of a repo. But the last part is that it's also totally inconsistent. That testing you're doing with that gem file, that doesn't match ChefDK where you're doing your development on your workstation, and the versions of Ruby are totally inconsistent with what you're running in production in your Chef client. That example there was a pretty simple setup. It was Ruby 2.18, right? Well, Ruby 2.18, that was current if you're using, Chef early 12 series, but if you're on 12.19, if you're on our latest release, 13 or anything past that, you're going to be on Ruby 2.3 or 2.4 potentially in the future. So what you're testing there is not actually what you're using. So how would we do this right? Like, how do we test in a way that is consistent and obvious to the user, and matches what we're doing in production? And the answer there really is that ChefDK is our tool. It is the one and the only. We're going to ChefDK locally, we're going to ChefDK in Travis, and we're going to use Chef in production. And because Chef and ChefDK match, that's going to get us a consistent worldview of our testing. So it's time for a little bit of automated testing. Obviously, we don't want to be testing by hand. We want this all to happen automatically, automagically, however you want to say it. And we're going to start with a basic ChefDK testing in Travis. I use Travis because it's simple and it's free, it's available, and that's what most people use. Some of these things are probably quite doable in other things like Circle CI or whatnot. I just haven't done them before. So this is a very basic ChefDK test. It gets us Chef versions outputted, and it gets us a nice little rate command that we run at the end. We'll show you what's in that rate command. So we'll break down the individual items. So the first thing that we're going to do is we're going to set sudo to false. That is ensuring that we're running in a Travis container environment. The containers are nice because they spin up really fast. The second thing we're going to do, and this is how we get ChefDK versus gems, is that we're going to use the apt add-on in Travis. It's quite a handy little add-on that they have. And that allows us to set up our repo. In this case, it's Chef Current Precise. You could use Chef Stable Precise if you wanted to make sure you were getting stable releases of ChefDK. And then we're going to install that package from that repo. So that gives us the exact same thing that you install on your desktop, assuming you had a Linux box, but really the same thing if you had Windows or Mac. Then we're going to skip the install. Running this echo skip bundle install ensures that we don't actually install the gem file, even though Travis has detected that we are on a Ruby distro, or Ruby repository, that is. And then we're only going to run builds against master and PRs. And this ensures that we don't double test, which can be pretty costly once we get into full testing, where some of the tests take a little while. We want to make sure that we use ChefDK, so we need to run the init. If you remember, maybe the first time you set up ChefDK, you stick this command into your bash profile. This ensures that you get all the paths and everything set up for ChefDK. So we want to make sure that when somebody types Food Critic, that they're getting it out of ChefDK, and this will ensure that all happens. And then this is the scripts. So scripts are the actual tests that we're running. The first 2 things we're doing here is just outputting the versions of all the tools we have. This is really handy when you're looking at job output and you're like, oh, that's really weird. Like, how did this happen? And you go, oh, okay, cool. I'm on Chef, 12.19 now, and I'm on Cook Style, whatever, Food Critic, whatever. Just make sure you're testing a little simpler or debugging a little simpler. But the actual meat of this test here, other than a little bit of debug information, is that we're going to execute rake. And we'll break down into what our rake setup is. But really the reason that we're going with rake is rake provides us a nice consistent UX. Rake allows a person who's doing local testing to run these commands, and it also allows us to do that same command in Travis. So we don't have to kind of like worry about what the command flags the person would run on the command line would be. Like we can all wrap that up and kind of like hide that, mask that complexity from the user who's doing testing. And that gives us a nice simple UX like this. So you have rake spec, we have rake style, that breaks down into a few, and then we can also even do a style autocorrect. So this is our Rakefile. It is a little ugly. I wouldn't worry about exactly what's going on in this. This is something you can completely just copy and paste from some of our repositories. A lot of what is in here is error handling in case you're not running it correctly. So we namespace our Rakefile. That gets us groups. That gets us a namespace of style here, and within styles, a few different tasks. Here's the individual tasks. We're wrapping all these things in rescues because we want them to fail properly if they're running for a non-ChefDK user. And then we set a default task because we want a person to just be able to type rake. We want to do the right thing. So if a person just types rake, they don't provide it with any namespaces or anything to run, they'll get the style namespace and they'll get the spec namespace. And that will be a complete test as far as we're concerned here. And the end result for this is basically a test that actually occurs. So on the right, you'll see our PR, Travis ran, and on the left, you'll see the output of the Travis run. You can see that it went through Food Critic, it went through Rubicop, which is cook style in this case, and it exited with a 0. So our test was good. So ta-da, we're all done, right? Like that was pretty cool. We have that running in Travis. We have a full ChefDK based test, and we're doing it all without having to worry about managing the dependencies of any of our tests. We don't have to like worry about bumping Food Critic. We don't have to worry about like, maybe a version of Rack that blows up with other things on certain versions of Ruby because that's all handled by Chef itself, right? But we're not done. And the problem is we have a hierarchy of testing usefulness. At the very top here, we have cook style and Food Critic, and then comes Chef spec, and then comes Test Kitchen and InSpec. And this is a little similar to kind of the food pyramid that you might see from the USDA, but really the thing to understand is that the thing that provides you the most usefulness is actually your Test Kitchen InSpec test. Like we want a full integration test. Without that, we're kind of kidding ourselves. Cook style and Food Critic are providing us with some consistent styling. It's making it so that when you share your cookbook, it's easier for other people to read and easier for other people to contribute to. Chef spec is really handy if you have very complex logic in your cookbook. You want to go through and test logic paths. You want to make sure that like when you're on a certain platform, you get a certain package, or when you're on a certain platform, a certain end result happens, the command changes, has a few extra flags. Chef spec is fantastic for that. But there's really no substitution for actually converging the node. You want to see, will this service start? Will my application install correctly when I'm on Ubuntu 16.04 or when I'm on CentOS 7? And you can only do that in Test Kitchen. So it's time for us to get complete testing set up. And we can do that now, thanks to some work that Sean O'Mara did. We have kitchen-dokken and this super sweet yet slightly sad picture here. We have Biden still in the White House doing his thing. And kitchen-dokken is a driver provisioner. It's an all-in-one thing for Test Kitchen that allows us to run Test Kitchen on Docker containers very effectively and quite quickly. Why kitchen-dokken? Well, we can run it locally on our box, which we could always do, right? With VirtualBox, we could always do testing locally through Vagrant. But we can also run it in Travis. And in Travis, we can't run VirtualBox. So this is very handy. We get a consistent way that we can run a local test and a test in Travis. But mostly it's crazy fast, right? So Docker containers spin up very fast. We don't have to download the Chef package for each of these containers that we spin up. We actually have Chef client installed on a container, and we mount that in, and that allows us to avoid that whole process of downloading the Chef client and installing it, which takes a little bit of time when you multiply it by 20, 30 tests. So this is what our Travis config looks like. It obviously gets a lot more complex, right? Like what we're doing here is significantly more complex, so we can't avoid the complexity. And we'll go over again like what each of these different items are and why they're there. So the first thing that we're doing is we're actually going to enable sudo, and we're going to set a distribution. And by enabling sudo, that gets us an actual virtual machine. It runs in Google Compute. And we need this because we can't run Docker in another Docker container. We need an actual VM. And then we also want it to be untrusted, because if we don't select this, we'll get precise, and the kernel will be older, everything will be older. It'll be less ideal. Docker is pre-installed on those VMs, which is super cool, but we do have to start Docker. So we're going to enable the service of Docker with just this one line, pretty simple. And then we're going to define a matrix. So what this matrix is the actual name of each of the test jobs we want to run, as if you were in Test Kitchen. So you can get this by just doing kitchen list, and you can kind of copy and paste these all into a matrix. And you'll see how we iterate over this and actually build out what we want to test later. Our before script gets a little bit more complex this time. We have to make sure IP tables is set up correctly. Then we do our same initialization of ChefDK, making sure it's in our path. And then our actual script, instead of running rake, we're going to run Test Kitchen. We're going to give it the location of the kitchen YAML file. And then we're going to verify with the instance variable that came out of that matrix. So what we'll get here is this command being run for each of those instances, or instances in the matrix, except instead of verify instance, it'll be default CentOS 7. Then we do one final thing, which is we want that same kind of linting that we were doing before. We want to run FoodCritic, we want to run Rubicop, we want to run ChefSpec, but we don't want to run it on every single job, because if we fail that linting, we want it to be very obvious that we're failing the linting. We don't want to fail every single one of these full system converges because we have an extra line that we forgot to Rubicop out. So what we do is we inject a job at the end of the matrix that is unit and lint equals 1. And it's a little weird, but we can do this with the special M setup here. And again, this is all available at the end, so you can kind of just copy and paste straight out of one of our repositories. So now that we have the Travis config set up, we actually have to configure kitchen-dokken. The kitchen-dokken config is a little bit different than probably what you're used to in a kitchen setup that you're using Vagrant for. So the first thing to understand is that Dokken is the driver, the transport, and the provisioner. That's a little bit different than you're normally used to. Normally you have a driver of Vagrant, and the provisioner is Chef. The provisioner here is Dokken, because Dokken only does Chef, and Dokken handles Chef through the container. So it has to do the whole thing. We also have to set the Chef version in the driver. Now again, because Dokken is handling Chef, it's pulling the container. We have to tell it basically what container to grab. If we say latest, we will get the latest Chef release, but otherwise we can specify the individual version, or we can use current, which will pull one of our current builds, which are effectively nightlies. Then we're going to define the actual container that we're using under the platform section. This is semi-similar to what we do in Vagrant, but obviously there's quite a bit more information here because containers are a little weird. So we have to define the platform, and we have to define the PID1 command, and that makes sure that the services will actually start up, which is a little bit tricky because Docker is not exactly meant for being a complete system. And we have to run intermediate instructions, which in the case of all these is going to be basically trying to decontainer containers. So we're going to install a few different things here. They're going to allow services to start up. You see systemd sysv, and you see init scripts. Also, we have to install a few things that make some of our final tests run in inspec. So we need lsof, we need which. Otherwise, some of those commands at the end will just fail. But in the end, this is what we end up with, like some beautiful complete testing here. We can run this through. We can see this in Travis. We had, an instance converge across CentOS 6.7, Ubuntu 12.04 to 16.04, and we ran 2 different suites. And then we injected that last little unit and lint equals 1 job. So you can see most of these ran within about 3 minutes, except for that first one, which is oddly long. And then our unit tests are obviously pretty quick because all that is installing ChefDK and then running that rake command. So there's some definite caveats here, and I can't stress these enough. Docker containers are totally not VMs. So containers are about half to a third of the size, depending on what the distro is, and they're missing a lot of packages. And because they're missing a lot of packages, they'll behave very differently. So you'll see in that some of those installs where we're doing apt installs or yum installs, we're trying to kind of get some of those packages back. We're trying to install the things we need to do in it, some of the things we need to do systemd. But even with all those packages installed, this container is still a container, right? It's meant for running an application. It's not meant to be a VM. It's not meant to be used really the way that we're using them. A lot of containers are totally missing the init systems, which is just super frustrating. It's hard to get these things working kind of the way you need them sometimes. And because of that, this whole thing is going to be a little bit of a time suck, in all honesty. You're going to spend some time mucking around, getting these containers working. You're going to spend some time trying to figure out why like an inspect test won't work because you're missing some random package like nettools, which you'll need to know if the ports are open. But, you know, that being said, like when this is all said and done, like you get wonderful full integration testing on your PRs, which is incredibly powerful because you won't spend time merging people's bad PRs. You'll know every time a person opens a PR if it's good or not. And that person could be you, or that person could be, you know, some contributor that you've never met. So the final thing I'll leave you with is we have two example repositories. On the Windows side, obviously, we can't do integration testing with Travis because we can't run Windows through Docker. It's just not, that's not a test. So we have lint and unit on our Windows cookbook, if you take a look at that. And then we have lint, unit, and the smoke, the full integration testing there with Test Kitchen, and that's on our ActiveMQ cookbook. These two stay pretty up to date. They're kind of like our example cookbooks for how to do these two things. So if you go and look at their Travis configs, if you look at the kitchen-dokken YAML files, you can kind of poke through all that and you can see what we're doing. You can see our Rakefile and whatnot. So hopefully you found this useful, and hopefully we'll see some more people testing with ChefDK and you know, with Docker, because it's pretty cool. So thanks for joining me today.